Today's lesson, students will write and graph linear inequalities. Sorry, that just covered that up there. Students will write and graph linear inequalities. Okay, what is an inequality? It's a statement that two quantities are not equal. Equations, we have an equal sign between two quantities. An inequality will have one of four symbols. The first symbol we have is less than. The next symbol would be greater than. Under that we have less than or equal to. And then finally we have greater than or equal to. So what are some words that might show up in a word problem that means these things? So less than, it might say fewer than. Or you might see the word under, below, lower. Words like that would mean less than. And if you had something where a greater than would be the situation, it'd be the opposite. You would have something like more than, or above, or over, maybe higher. Okay, less than or equal to. Okay, so for less than or equal to, you want to think about things like, say you've got $20. So you can spend exactly $20, or you could spend less than $20. So the words that you would expect to see in that sort of a situation would be up to, like you can spend up to $20. You can spend at most $20. You could spend a maximum of $20. You could spend no more than $20, or no higher than. So those are all phrases that could show up in a less than or equal to situation. So notice that, less than, you think of small. But if you look at the words that show up, maximum, more, up, most, higher, those all sound like words that would go with greater than. So you have to be really careful with the less than or equal to and greater than or equal to, because it kind of ends up being the opposite of what you would expect. So you have to stop and think about, wait, can I spend more than $20 if all I have is a $20 bill? No, the most I can spend is $20. So that means I can spend $20 or less. And so then for greater than, you might see things like at least. So an example that would maybe work for greater than would be an English teacher requires you to read 30 minutes or more each day. Well, that means it could be exactly 30 minutes or it could be more than 30 minutes. So one way you might say that is you need to read at least 30 minutes. Or you could say you should read no less than 30 minutes. Or you could say you'll read a minimum of 30 minutes. Or no lower than. Or some other kind of problem. Okay, so again, if you look at those, greater, you think big, but then you see least, no less than, minimum, lower, those all sound like words that would have to do with less than, but they don't. So be really careful when you see those phrases and stop to think about what they mean before you write an inequality. All right, so we've got an example here where we're going to translate some inequalities. So our first example is the capacity of an elevator is at most 12 people. So I'm going to use P for people, and 12 is the capacity. Now, could I have less than 12 people on the elevator? Absolutely. Could I have more than 12 people on the elevator? No. Could I have exactly 12 people? Yes, I could. So P would have to be less than or equal to 12. In our next example, we have there are more than 1,000 books in the library. So using B for books. Okay, so it says there's more than, well, that's the same as greater than, 1,000 books in the library. The only thing you have to ask yourself is, could it be exactly 1,000 books? So if I say it's exactly 1,000 books, is that more than 1,000? No. So it is just greater than 1,000. It's not greater than or equal to. So in this case, B would be greater than 1,000. All right, so on your whiteboards, I want you to write an inequality for minimum wage. Minimum wage is $9 per hour. So write an inequality. Think about, would you be willing to make less than $9 an hour? Would you rather make more than $9 an hour? Could you make exactly $9 an hour? Think about that. Pause the video and write down your answer. Okay, so if I use W for wages, if minimum wage is $9 an hour, I am certainly not going to settle for less than $9 an hour. It's either going to have to be exactly $9 an hour or more than $9 an hour. So the wage would have to be greater than or equal to $9. All right, and here's another one for you to try on your own. I can carry at most 7 passengers in my car. Okay, I can carry at most 7 passengers in my car. Pause the video and write an inequality for this situation. Okay, so if I use P for passenger, can I have more than 7? No, it has to be less than 7. Could I have exactly 7? Yes, I could. So it's P is less than or equal to 7. All right, so sometimes you may have to describe a solution using words. And so if we look at example A, 2P is greater than 8. It's not quite solved because we still have something in front of the 2. 2 times P is greater than 8, so since we are multiplying by 2, we're going to divide by 2 to undo that. So if you divide by 2, we get P is greater than 4. So to describe the solution using words, that means that P is all real numbers greater than 4. P is all real numbers greater than 4. So here's one for you to attempt on your own. Describe the solution of x minus 6 is greater than or equal to 4. So first solve it, and then describe the solution in words. Go ahead and pause the video now. Okay, so with this one, if you add 6 to both sides, you get x is greater than or equal to 10. And so you could just say that. X is all real numbers greater than or equal to 10. Or you could also say x is at least 10. X is a minimum of 10, and so on. So you could also say it using the phrases that we had in the chart up above. All right, so when we graph inequalities, we graph them on a number line. So you can graph the solution set of an inequality on a number line. So for example, here we have x is less than 6. They have an open circle, or a circle that's not filled in, on the 6, and then the numbers that are less than 6 are going to the left. So we use an open circle, and again, that's a circle that's not filled in. We use an open circle for less than or greater than, and the reason we do that is because the point is not included in the solution. Point is not part of the solution. 6 is not less than 6, so the point is not included. But of course, 5.9999999 is less than 6, so. And then if it is a less than or equal to or greater than or equal to, well, since it can equal the number, then the point is included in the solution. So we used a closed circle, which is a circle that's filled in. So the point is included when we have a closed circle. Okay, so for example, to graph the inequality b is less than negative 1.5. So first I need my number line. So I'm going to draw myself a number line. And I know negative 1.5 is going to be between negative 1 and negative 2. So I've got negative 2, negative 1, 0. All right, so this is a less than. So it can't be exactly 1.5. So I'm going to have an open circle on 1.5. Well, first let me mark my negative 1.5. I'm going to have an open circle on negative 1.5. And it's the numbers that are less. So the numbers that are getting smaller are going to the left. And so that's how your graph would look right there. An open circle on the negative 1.5 with the arrow going to the left. So on your own, I want you to try graphing c is greater than 2.5. Pause the video and do the problem. Okay, so when you graphed that, you should have had an open circle on 2.5, which is halfway between 2 and 3. And the arrow should be going to the right, because those are the numbers that are getting larger. Okay, another example here we have 5 is less than or equal to t. Well, that means that t is actually greater than or equal to 5. And so you're going to run into less problems if you switch it around before you graph it. So I'm going to flip it over, and I'm going to say t is greater than or equal to 5. And that way, I'm less likely to make an error when I'm graphing it. So we've got 4, 5, and 6. Now in this case, it's less than or equal to, so I need to use a closed circle. I mean greater than or equal to. I need to use a closed circle. And then again, t is greater than 5, so it's all the numbers that are getting larger, so it's going to the right. All right, so on your own, I want you to attempt this problem. Simplify the left side, and then remember to switch sides before you graph it. Flip it over and put the W on the left side. Pause the video now, please. Okay, so when you simplified the left side, you got 4 minus 4 is greater than or equal to W, and 4 minus 4 is 0. So again, before you graph it, flip it around. W is less than or equal to 0. And so that means that we've got a closed circle on 0, and it's less than, so it is going to the left. Okay, now on occasion you'll have a word problem that you need to write an inequality for. So for example, the members of a lightweight crew team can weigh no more than 165 pounds each. We're going to write an inequality for the acceptable weights of the team members. So I'm going to use W for weight. So they can weigh no more than 165. So is it okay if they weigh less than 165? Yes, it is. Could they weigh exactly 165? Yes, they can. And so W would be less than or equal to 165. So when I graph that then, I'm going to use a closed circle on 165, and my arrow will be going to the left. So on your own, I want you to try doing this problem. A trainer advises an athlete to keep his heart rate under 140 beats per minute. So go ahead and attempt this one on your own. Notice the word under. Pause the video now. Okay, so the heart rate has to be under 140 beats per minute. That means it has to be less than 140. It can't be exactly 140 or it won't be under 140. So H is less than 140, and so we'd have an open circle on 140 and the arrow would be going to the left. This concludes the lesson on writing and graphing inequalities. Thank you for watching.